All right, so welcome to the review day. We are going to be going through the review for your summative, which is tomorrow. Now, this review is super similar to what you are going to be seeing on your summative. A lot of these questions are almost mirror images of that. So please make sure that you're following along and actually understanding what you're doing, not just copying. If you do have questions, feel free to raise your hand and I'll come over and do what I can to help. So, first question, find the sum. Write your answer in scientific notation. I'm actually going to box this because I want to remember at the end that I need to put that in scientific notation rather than leaving it in any other notation. What we've learned today, or yesterday rather, is that if we are adding or subtracting, we need to check the magnitudes. If the magnitudes are different, then we need to get the larger magnitude to be equal to the smaller magnitude. So I subtract 1 from that 6. Let me erase these so it's easier to see. I subtract 1 from that 6. So now what I have is 5.32 times 10 to the 5th. And because I subtracted 1, I know I need to move this 1 place to the right, because as we saw today, or yesterday by your standards, if we move right, we subtract, and vice versa. If we subtract, we move right. So I have 5.32 plus 67.8. So then I add these. I add a little placeholder there. 2 plus 0 is 2. 3 plus 8 is 11. I add the 1 up there. I have 7 plus 5, which is going to, or 6, which is going to give me 13. And 7, my decimal place comes down. So I have 73.12 times 10 to the 5th. However, you should remember that this is in bad scientific notation. I cannot have that, so I need to move this decimal place back 1, which means when I move left, I add, and I end up with final answer of 7.312 times 10 to the 6th. Now, there was a question that a lot of students asked on Tuesday, which was, why are we doing this part? Why are we doing this, where we're subtracting 1 from the 6? Here's the basics of it. You need your magnitudes to be the same when you're adding or subtracting in scientific notation. Here's why. If I were to put these numbers into standard form, 5.32 times 10 to the 5th moves 5 times 1, 5. I get, let's erase that. I get 532,000. I can't just add this to this, because when they're not in scientific, or when they're not both in standard notation, 532,000 can't be lined up with 6.78 times 10 to the 6th. That needs to move 1, 2, 3, 4, 5, 6 places, which means that in order to get these to line up, the 7 is actually in line with the 5 and the 8's in line with the 3. It's not like this 6 is in the same place value as the 5. It doesn't work that way. So we need to get them in the same area by doing this subtracting of 1, which then shifts everything over so that we can actually deal with it. Great. Now, switching gears slightly. Make sure we have the red pen. 4 to the 3rd divided by 4 to the 5th to the 3rd. Now, as we remember, there are a couple rules of exponents that we need to keep in mind here. First is the power of powers rule, which states that we are going to first distribute the power into here, which means we are going to have 3 times 4 to the third, so we have 4 to the 9th, and we have, that's divided by 4 to the 15th. Now, we multiplied here, we see the division symbol. The division symbol means we subtract only the exponents if we have like bases. In this case, our bases are alike, therefore we can just subtract. So I come over and I write my base again. I'll then write my exponent. I see I'm dividing, so I'm going to subtract 9 minus 15, which is going to give me 4 to the negative 6. Now, 4 to the negative 6 is bad exponent notation. I want to change that. I remember that negatives flip. Remember, negatives flip. Only, though, negative exponents flip, not negative bases. Negative bases are a whole different thing. Only negative exponents flip. So I get 1 over 4 to the positive 6. Here's another common misconception. When this negative brings everything underneath the 1, like this, the negative is now gone. You're done with it. It does not matter anymore. Similar to, let's say I switched it and, I don't know, let's say 1 times 3 to the negative 6th. If I flip that back, that means that it's 3 to the 6th over 1, but we don't really need the over 1 because that's implied, so it's just 3 to the positive 6. When this negative brings it across the fraction bar, we get something completely new. Okay, so my final answer is 1 over 4 to the 6th power. And note, it said simplify, not evaluate. If we had to evaluate this, we'd have to take out the calculator and say 4 times 4 times 4 times 4 times 4 times 4. And we don't want to do that right now because we don't have to. Now, next piece. Will the product of this expression be positive or negative? Well, let's remember a couple of things. If things are inside the parentheses with a negative, we have to look at this. If they're outside, so let's say this was 8 to the 24 outside of parentheses, this is always negative because this gets attached after you evaluate the rest of this. But they're inside the parentheses, so what we need to do is this. We need to say, well, is this positive or negative? I'm sorry, not positive or negative. What am I talking about? Is this even or odd? If it is even, as you see in your notes, if this is even, the answer will always be positive. Because a negative times a negative is always a positive. So if it's even, there's always going to be even pairs of 2, so it's going to equal a positive. If it is odd, so 1, 3, 5, 7, so on and so forth, then it's going to be negative. So in this case, 24 is even, so the product of this expression will be positive. Okay, now we have to simplify the expression. Now, I'm going to come over here and just write, please email my dad a shark, just so I can remember this. I'm going to do things in the order that they happen. So we have parentheses first, parentheses, and they're done. Exponents. This is kind of where we have to apply this rule. So I'm going to apply the exponent here. So what I really get as my next step is 8 to the 2 times 8 to the 3 divided by, make sure that's really clear so you don't see the subtraction. I heard that was an issue. 8 to the 6. Now, remember, this is multiplying, not adding, because I'm raising a power to a power. Power of power rules. So these multiply. I don't have 8 to the 5th. That is wrong. I have 8 to the 6th. Now, I've done parentheses, I've done exponents. Now I have to do multiplication and division in the order they happen. First thing I do, make sure my bases, what in the world? Make sure the bases are the same. All my bases are the same, therefore I'm going to rewrite my base. And I'm going to say 2 times means plus, 3 divided by means minus 6. So, I'm going to get rid of this, I have a little room to write. What that means is I have 2 plus 3 is 5 minus 6 is negative 1. So I have 8 to the negative 1. And I encourage you to take a moment to think about what that means. Going back to this example, and hopefully you will have realized that that is in fact equivalent to 1 over 8 or 1 over 8 to the 1. Because remember, this has an implied power of 1. You don't have to write it, but it is there. Great. Next, we see this. Right here, there's an implied multiplication symbol because there are two parentheses pressed against each other. We're going to use that to do this next step. Now, what we're going to do in order to code these in the right colors so that you can see it, our powers we're going to do separately because we're multiplying or dividing. We're going to do them separately from these. So I'm going to say 3.2 times 5.1, and I'm going to do that multiplication separately. So 1 times 2 is 2, 1 times 3 is 3. Put a placeholder. 5 times 2 is 10, 15, 16. So I get 16, I get 2, 3, 6, 1. I circle anything after my decimal places. I have two things, so I go 1, 2. I get 16.32. Now, in order to do my powers of 10, let me move this. No, it's not going to let me move it. Let me do my powers of 10. So I really have 10 to the 4. I'm multiplying, so plus 5, which is really 10 to the 9. So times 10 to the 9th power. However, this is ugly scientific notation. I need to move this decimal such that I only have a number between 1 and 10 in this area. So I end up with 1.632 times 10. And I moved to the left. See, I moved to the left. So I add 9 plus 1, which is 10. So I end up with a final answer of 1.632 times 10 to the 10th. Great. Next question. The population of Denver was 5.7 times 10 to the 5th power in 2005. By 2015, the population of the city had increased by 1.1 times 10 to the 5 power. What is the total population of the city in 2015? So what I encourage you to do is actually take a moment and go ahead and func this and see what you're seeing. So the population of Denver was this. It increased by this. So I'm going to write boxes around that. I'm going to underline increase, and I want to know the total population of the city. Now, something that I note they didn't mention in this question was this. How should I show my answer. They didn't tell me if I needed to do in scientific notation or in standard notation, so really I can do whatever I want. So I'm going to do this. Make sure, sorry, I shouldn't have. What is the total population? Well, I know the word increase typically means addition, so I'm going to say, well, 5.7 times 10 to the 5 plus 1.1 times 10 to the 5. First thing I check is, are my powers, my magnitudes the same? They are, so it's going to end with times 10 to the 5. I have very little work to do here then. I'm going to add. That gives me 8, gives me 6, 6.8, 6.8 times 10 to the 5. I see that this is in proper scientific notation, so I leave it. It's done. That's all I need to do. This is a very simple question. Now, on to some slightly tougher questions. I'm going to show you number 7, I'm going to show you number 8, and then I'm going to encourage you to work on the remainder of these on your own, because none of these others are super tough. We'll also address really quickly question 15. So, what is the value of this expression? The numerator is first being multiplied, then it is being divided. So let's do the multiplication first, then the division. So I remember when I multiply, I need to do each piece separately. I'm going to do my factors first. 2.5 times 5. Well, that's going to give me 12.5. Just so you see, it's 5 times 5 gives me 25. And then 12. So I get 12.5 times 10. Sorry, let me do that in the red that I've been using earlier. Times 10. Well, 18 plus negative 10. 18 plus negative 10 from the two powers that I already have gives me 8. However, this is bad scientific notation, so I'm going to move that. So I really end up with, I move to the left, so I add 9. So I end up with 1.25 times 10 to the 9. All of that over 3 times 10 to the 4. Now, whenever you see things like this, you deal with each piece individually. 1.25 divided by 3. Well, 1.25 divided by 3. I'm going to say 3 can't go into 1. 3 can't go into 12 4 times. I get 12. And I get 0. And then I bring down the 5. 3 goes into 5 one time with finger of 1. And then I end up with 3. Bring in my decimal. 3 goes into 10 3 times. And then I get 9. And then I see this is going to be an endless loop. So I get 0.413. 0.413. And if you check a calculator, you'll get the same thing. I get 0.413 times 10 to the 9, and I'm dividing minus 4. 9 minus 4 is 5. 0.413 times 10 to the 5. But I'm sure you've already noticed this is bad scientific notation, so I need to move this 1 to the right. To the right means subtract, minus 1 So I really am going to end up with, this is going to get a little weird, but I'm going to come up here just so you can see this transition of here moving to here. 4.13 times 10 to the 4, because I subtracted here, because I moved to the right with this decimal. Great. Of the two quantities below, which one is larger by how many times? Well, first thing I see, that's larger. Immediately, I see that immediately because 8 is bigger than 5. Now, that's not the only question though. I make sure I just did a really bad job of showing this example. Which is larger? I first answer that question. I need to make sure I answer by how many times. So if I want to find out by how many times, I divide. And again, I'm going to divide each piece individually. Each piece individually. So let's start with the 10s because they're easy. That's 10 to the 8. I'm dividing, so I subtract. So 8 minus 5. 8 minus 5 gives me 3. Let's do the slightly tougher piece, which is 6.75 divided by 1.35. And in order to save time, I'm actually going to just simply come in and say, well, let's pull up the calculator. Should I pull up? I make sure that it is in fact in scientific form. You can do that by clicking here. There's no reason to be using a standard calculator in 8th grade. And I say 6.75 divided by 1.35. And I get 5. So, thank you, calculator. I get 5. I check to see that this is in scientific notation. That number is, in fact, between 1 and 10. So, we're good. It is 5 times 10 to the 3 times, let me finish answering the question, times larger. So, in order to really get full points on this, I would need to actually write this. 6.75 times 10 to the 8 is 5 times 10 to the 3rd times larger than 1.35 times 10 to the 5th. Now, by putting that, this right here is a good answer. This is going to get me full credit on my summative and on the IAs and everything else. This is a clear answer. If I just put this part, I don't know which number is bigger. I don't know which number is smaller. That doesn't help. I need to know that this number is 5 times 10 to the 3 times larger than this number. Now that you've seen this one, please go down and do number 9. Pause the video now. Great, welcome back. I'm going to skip past these numbers because hopefully you remember you need to divide these. Then you need to divide these. Here, hopefully you remember that you need to multiply your magnitudes by each other. And you need to multiply your factors by each other. This, number 12, should be reasonably simple. Here, remember that you apply power of powers rule and then you simply subtract your powers. The commutative property of multiplication, I'm going to actually have you Google the commutative property of multiplication and give this one a shot because it's actually rather interesting when you get to read it. So again, the best way to do that is to go to Google and Google commutative property. Thanks, guys. Commutative property. So moving things around, which states simply that A plus B is the same as B plus A. So go ahead and apply that same logic in this problem. Now, simplifying for number 15, because I think this is one that I've seen a lot of people make very silly mistakes on, so I want to address that. We need to check our bases. Here we have the 9s, we have the 2s. I'm not going to combine them. They're not like terms. So we'll go red for the 9s. 9 to the squared times 9 to the 4 is the same as 9 times 2 plus 4. That's going to give me 9 to the 6. Therefore, as hopefully you've already seen, that's going to then be times 2 to the 8, because 3 plus 5. Remember, multiplication of exponents, only multiplication of exponents gives you this. Now, one other thing that I want to address that is not on here that I've seen a bunch of people have asked me about. Mr. Z to the 0 power is equal to 1, right? And I say yes, and then they say, okay, then Z to the 0 power is equal to Z to the first power. This is wrong. Here's why. Let's say Z were actually 1,000,000. A million to the 0 power is equal to 1. 1,000,000 to the first power is equal to 1,000,000. These two things are not the same. So when you have something to the 0 power, the whole thing is equal to 1. This whole thing disappears and it equals 1. A number to the 0 power is equal to 1. It is not equal to that number to the first power. Hopefully this has been helpful. If you do have any questions, please feel free to raise your hand. The expectation is that you finish the remainder of this with the time remaining. You are working 100% silently, and you are raising your hand with any questions. Thank you all